Hey class, Absolute 5 here, and today we're going to talk about factoring of the form ax squared plus bx plus c. Now this is slightly different because there is going to be a constant or numerical coefficient in front of the trinomial. So that's what's the difference between this video and the last video. We are factoring trinomials of the form ax squared plus bx plus c, such as 3x to the third, 3x squared plus 11 plus 6, 8x squared minus 22x plus 5, and 2x squared plus 13x minus 7. So how do we do this? Well, I was taught the AC method. What's the AC method? Where you take the constant here, the numerical coefficient, and you multiply it by this constant at the end, thus giving you a slightly new equation. So it'll be x squared plus 11x plus 18, and then you use the same logic where you have to think of two numbers that multiply into 18, but those same numbers have to add up to 11. So let's think of 18. We got 18 times 1, we got 9 times 2, or 6 times 3, and yeah, that's about it. So 18 and 1 won't work because when you add them, you won't get 9. You get 19 instead of 11. 9 and 2 actually work out very well, but here's the difference though. You're not going to put this as x squared plus, you're not going to put this as your answer. Because you're going to get this one, but we want the original equation from the beginning. So where did that 3 go? So this will not be right. What you need to do is rewrite this as 3x squared plus these two factors. So it'd be 9x plus 2x plus 6. In any order, I could have rewritten as 2x plus 9x instead, but in this case, it's actually good to write in this way because we can factor by grouping. So 3x times, well, not 3x, that's going to be x plus 3, and I factor out a 2 since they're both even numbers, plus 2. I'm left with x plus 3, and now, like how we did before, we identified this will be 3x plus 2 times x plus 3, and this will be your answer. This will guarantee you'll get the original equation you first started off with. So it's called the AC method, where you multiply the numerical coefficient with the last constant, which is c. Get it? AC. Basically, you take A and you multiply C. That's basically the idea. So we'll do the same thing here. 8 times 5 would be x squared minus 22x plus 40. So now we got to think of our list. Two numbers that multiply into 40, but when you add them, they'll give you negative 22. This smells like two numbers that need to be negative. So let's think of the two numbers. So let's see. 20 times 2. 10 times 4, 8 times 5, and I think that's about it I can think of at the moment. There's probably more, if not, then I think these are enough. So 20 and 2 fit the profile already very well. I just think they just both have to be negative. Because if they're both negative, when you multiply them, you get a positive, and not only that, you add them, you get negative 22, which works out perfectly. So then we have 8x squared minus 20x minus 2x plus 5. Now, here's the thing. Let's see, can this work as factors? Let's switch it around. I feel like if I switch it around, it'd be a little bit easier for me. So I'm going to switch the 20 with the 2. So I'm left with 8x squared minus 2x minus 20x plus 5. Why am I doing that? Because when I factor out a 2x, I'm left with 4x minus 1 here. Then minus 20, so 20 has to, let's see, so for me to get negative 20 here, I have to factor out a negative 4, which makes this a positive 5x which would be, no. Wow. Okay, that was bad. Okay, that was completely bad. Okay, scratch what I just said. Scratch that. All right, let's try this again. Let's factor out a 4 in both these two terms. 4x, more or less. So now I'm left with, what is this? This will be 2x minus 5. Ah, I see. All I have to do to fix the situation is factor out a -1. Why? Because I'm left with 2x minus 5, which is exactly what I need, because when I multiply this back, I get the same thing. Ah, okay, good. So I'm left with 4x minus 1 times 2x minus 5, and that is my factors to get the original equation. All right? I apologize for that first step. I thought I wanted to be a little fancy, but I screwed up, so I'm exposed. All right, same technique here. 2 times 7 would be x squared plus 13x minus 14. Two numbers that multiply into -14, but when you add them, you get positive 13. So we got 7 and 2, and 14 times 1 as well. So 7 times 2 gives me -14. I can do that, but when I add them, it doesn't get me 13, so we scratch that. So let's use 14 and 1. I think 14 and 1 works perfectly. You just have to make the 1 negative, because if you made the 14 negative, you get -13, and you don't want that. So plugging this in back to our original equation, the middle term is replaced. I totally forgot to mention that this whole time. Sorry. It's too late, whatever. You're supposed to replace the middle term with the two factors. That's what I mean to say this whole time. Sorry. Anyway, I'm pretty sure you figured it out at this point anyway. So, 14 and 14x minus x. So we don't put 1, you just put x to indicate it's an x. It's a 1. Minus 7. Okay, I bring this two terms down. Let's factor out a 2x here. I'm left with x plus, wow, not 2, 7. And for this one, I can factor out a -1 to get positive x, positive 7 to get 2x minus 1 times x plus 7 as my answer. Let's continue going down. Factor, holy crap. Yeah, no. I'm sorry. I blanked. This should still work. X squared minus 13xy minus 30y squared. Okay, that's fine. So same idea. Two numbers, when you multiply, gives me -30. And the same two numbers need to be -13. Okay, this is going to be interesting. So we got 30 and 1. 30 times 1. We got 10 and 3. We got 6 times 5. And we got 2 times 15. I think by looking at this, I know 30 times 1 is not going to work. 10 and 30 might work. They would have worked. It would have worked if the middle term, actually, if the middle term was positive and the other term was positive, it might work. But the reason why it doesn't work is because if I make one positive and one negative, no matter what, I'm going to get 7x in the middle. So that doesn't work. 6 and 5 doesn't even give me 13. So 2 and 5, or in this case 15 and 2. When I make 2 negative, actually no, we want 15 to be negative because we want it to be negative when we add them. So now we go back to our original equation, 10x squared minus 15xy plus 2xy minus 13y squared. All right, so now we need to group these terms. All right, so let's group, well, they're actually fine the way they are, actually. So let's factor out a 5x in both terms. So we get 2x minus 3x, oopsie, not x, we're left with y. And for the second term, all we have to do is factor out a y, and I'm left with 2x minus 3y, and well, there you go. That worked out very nicely, actually. So I'm left with 5x plus y times 2x minus 3y, and those are my factors. Let's see. Okay, we got 2 more left. Same idea. We got x to the 4 minus 5x squared minus, not 8, 24. So we need 2 numbers. When we multiply them, we get 24. Not 24, negative 24. And then the same 2 numbers, when we add them, gives me negative 5. Well, let's think. We got 24 times 1. We got 12 times 2. Excuse me. We got 8 times 3. And we got 4 times 6. All right. I think 8 and 3 looks like the ones that are going to work, because this is not going to work. That's not going to work. Even that's not going to work, because I'm already thinking of the terms when you add them in the middle. So therefore, 8 is going to be negative and 3 is going to be positive, because when you multiply negative 8 times 3, you get negative 24. But when you add the 2 numbers, you get negative 5 in the middle. So I'm left with 3x to the 4 minus 8x plus 3x minus 8. Let's reorder that, actually. It's much easier the other way. Plus 3x minus 8x. Why? Because you can kind of see common factors already. So I factor out a 3x here. I'm left with 3x to the 3rd. And then I'm left plus 1. And then I'm left with minus 8. I factor out negative 8 in both terms. X plus 1. Oh, I'm sorry. It wasn't supposed to be x. These are supposed to be squared. Sorry, they're supposed to be squared. So then now that makes more sense. I can factor out an x squared, and this would be x squared here. And then, staring me in the face. The 3 wasn't supposed to be there. Sorry. Sorry. So sorry. Now that makes sense. Now we're left with 3x squared minus 8 times x squared plus 1, and that works out. Good job. Good job. Alrighty then. One more. X squared minus 11x plus 12. Oh my gosh. 24. Okay. Same 2 numbers that multiply give me 24, and same 2 numbers when I add them give me negative 11. So it's 24 times 1, 12 times 2. We have 8 and 3. I believe 8 and 3 definitely work. But they both have to be negative, so that's why I get the negative 11. So I'm left with, let me double check, what was our original equation? Okay, it's not to the 4th, it's to the 2nd. Okay. 2x squared minus 8x minus 3x plus 12. That's in perfect form, so we're going to factor now by grouping. And I factor out a 2x, I'm left with x minus 4, and I factor out a negative 3. So this way I'm left with x and negative 4, because when I multiply back, I get the same answer. And now we have 2 of the same terms. I'm left with 2x minus 3 times x minus 4 as my answer. So I want you guys to try that last one for yourselves for homework. So that's the lesson for you guys. It was very, very extensive. I'm pretty sure you enjoyed it. And be sure to leave your answers and comments down in the comment section down below. And that's the lesson for you guys. Be sure to like, share, subscribe to my channel. Mash the bell button for more content. And I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate, man. Just calculate.